Page 440, number 45, is an example of how we can use the law of sines to triangulate the position of an object. And it was used a lot, and it's done through computers now, but the idea is the same. Finding a position of a ship offshore where two fixed points, and in this case it's two lighthouses, one at point A and one at point B, are trying to figure out the exact location the ship is from the coastline, because it could be rocky, the sea might not be super deep there, so there'd be reasons why you would definitely want to know the exact position of your ship. So we know that the two fixed points are 20 miles apart, and we know that we have an angle of 52 degrees from lighthouse B to the ship along the coastline, and then we also know that the ship makes an angle of 33 degrees from a point straight out from lighthouse A to where the ship is based on its location to point B. So with that, what we want to find is we want to find side B and we want to find side A. We want to find both of those sides because we want to find its distance from both lighthouses. So what we do know for sure is we know what we can call side S, which is 20 miles, and we know angle S. So that is going to be the one we're going to be working with in both of our law of sines ratios. Now, we have two of the three angles, so we can go ahead and find the last angle that we need, which is angle A. And since we have a triangle, we're going to take 180, and we're going to subtract the 52 degrees that happens at lighthouse B, and the 33 degrees, which is near the ship. And when we do that, we get that angle A is 95 degrees. So not a right triangle, close to it. It does look like a right triangle, but you can't make that assumption. So now we will start with side A. The distance from lighthouse A to lighthouse B to the ship is side A. So we're going to do sine of S over side S is going to equal sine of angle A over side A. So we're going to get that the sine of 33 degrees over 20 miles is going to equal the sine of the angle we just found, which is 95 degrees, over side A, which will be the distance from lighthouse B to the ship. So solving this for A, rearranging our terms, cross multiplying, we get 20 miles times sine of 95 divided by the sine of 33. Putting that in the calculator, we get that length is 36.6 miles. So this side length is 36.6 miles from the ship to lighthouse B. Now doing the same thing to find the distance from lighthouse A, we're going to do sine of S over side S is going to be the sine of B over side B. So the left-hand side ratio is going to be exactly as it was in the first part. So we have sine of 33 over 20 miles is going to equal sine of our other given angle, which was 52 degrees, over side B. So B is going to be, when we cross multiply and rearrange, 20 miles times the sine of 52 divided by the sine of 33 degrees. And when we put that in the calculator and simplify it, we get 28.9 miles. So the distance from lighthouse A to the ship is 28.9 miles.